All right, we are live. You are in the right place if you're here for a free live lesson on geometry. Today we are talking about similar shapes. If you're here and you can hear me, give me a plus in the chat or let me know that you're here in the chat so I know that I'm not just speaking to myself in my own world. But let me know if you're here. Say hi, whether you're returning or new. Welcome. We'll shortly go into an intro, but for the time being, if you can check under the video in the description, you could find a link to a workbook for today's lesson. A workbook for today's lesson to help you follow along. But if you're here, thank you for being here. This is a free lesson on geometry on similar shapes. If you want to chat, you might have to subscribe to the channel first in order to be able to chat and for you to participate and get the full experience of being in my course. So go ahead and do that as well on YouTube, or I know we're also on Facebook and Twitch as well today. And yeah, if you're here, go ahead and copy that link at the top of your browser, share it with a friend, share it with a family member. Yeah, and join the fun. A little bit about me. I'm Eddie. I'm the senior math teacher at my EdSpace. I've been teaching for 9 years, high schools and colleges, private tutored every grade level from 6th grade math all the way to students preparing for graduate school. I did really well in school myself. I got A's in all my math classes, got a perfect score on the SAT, and got into my dream school at UCLA. From UCLA, I graduated with a mathematics major, a pure mathematics major degree. And after that, I started teaching and knew right away that I loved teaching. I was so passionate about teaching, and it showed because my students got into some of the top universities in the nation and perfect scores in the SATs and all that. But most importantly, they had fun doing it. And that's what we're here for today. We're here to have fun. We're here to learn math and have fun doing it. So without further ado, let's begin. Hi, Maddie. Welcome back. All right, here is our APK, also known as accessing prior knowledge. I love starting off my lessons with something like this, just to get our gears running again, get our brain activated. Right now, it is 6 p.m. on the West Coast, but on the East Coast, I know many of you are joining in at 9 p.m. So it is a lot later in the evening. You might have had a long Monday, but here we are getting our brains reactivated. Here we go. So we have two shapes that are similar if they are the same shape, just a different size. That's what we call dilation. If we have the same shape, and whether we're making it bigger or making the bigger shape a smaller shape, and the two shapes stay similar, that's what we call dilation. Same shape, just different size. Given that the following two triangles are similar, find the missing value of x. So let's take a look. Right here, we know that these two triangles are similar because they tell us the two triangles are similar. So we don't need to prove anything. We just have to set up some equation so that we can find what this missing value of x will be. So we have two angles that are congruent. And then we have these two sides in between the two angles. So we know 3 will be proportionate to 10.5. So we can write 3 is to 10.5 as 5 will be to x. 5 is to x. Now, I could have set this up in a different manner as well. Right now, I'm going to have to multiply both sides by x, then do everything else. However, what if we set this up so that x is the first thing we begin with, so that on both sides, we don't have to multiply by the variable, but multiply by something else. So in this case, x is proportional to 5. And therefore, if x is proportional to 5, then 10.5 will be proportional to 3. And now all we have to do is multiply both sides by a 5. Oops. So the 5s cancel, giving us just an x is equal to 5 times 10.5 is 52.5 all over 3. And now, is 52.5 divisible by 3? Let's see. 3 goes into 52.5 wholly about 17 times. 17 times 3 is 51. And then we're left with 1.5 divided by 3 is 0.5. Now, we're not done. Whenever we are looking for missing values or unknown values, we always have to make sure we're using the units of measure that we're given. Great, Maddie, which is in this case, centimeters. Awesome. So x is equal to 17.5 centimeters. If you miss out on that centimeters piece, you wouldn't get full credit for this question. Okay, so please keep that in mind. All right, next page, we have similarity. Given that the following two quadrilaterals are similar, find the missing values. So here we have 10 centimeters, 9 centimeters, 16 centimeters, x, y, 20. So this time we have multiple missing values. What's a proportion that you would be able to create from this, given our APK in our previous slide? What would be an equation that you would be able to set up here in order to just find one of these variables? And while you think of that, let's think about this. We have a y and a 20. So we can technically say, okay, y is to 20 as maybe 9 is to x. But this might not work because we now have an equation with two variables, with two unknowns. Whenever we have just one equation with two unknowns, impossible to solve, right? Unless we guess and check all the way, impossible to solve. So instead, what we do, we must create an equation where we only utilize one of these variables, where we utilize only one of these variables. So in that case, what we can do, we can start by using the y's. So we can say y is to 20, y is to 20. And now let's think about what other numbers we can use here, because we don't want to use the x. So that's how we know we don't want to use the 9. Instead, we're going to use the 10 and the 16, where 10 is to 16. So now 10 and 16 have common factors. So we can divide both 10 and 16 by the common factor of 2. So that becomes a 5, 16 becomes an 8, and now we'll multiply both sides by a 20 in order to cancel out this 20 on the left, leaving just a y. Great, Maddie. I saw you. 16 over 10. So now we have y is equal to 20 and 8 have common factors of 4. So 20 divided by 4 is 5. 8 divided by 4 is 2. Now 5 times 5 is 25 over 2. This is also known as 12.5. And this is in, don't forget, centimeters. Now we're not done with the problem because we were asked to find the missing values, plural. Right now we just found y is equal to 12.5. Now I need to look for x. How do I do that? Let's set up another proportion. We can set up, and let's do this one in green. For x to 9 centimeters, we can use the proportion, the fraction that Maddie showed us in the chat. We can go 16 to 10. Now, can we put 10 to 16 here instead of 16 to 10? Instead of saying x over 9 is equal to 16 over 10, would it be the same thing as saying x over 9 is equal to 10 over 16 in the chat? Would those two be the same thing? Setting x over 9 equal to 16 over 10 and x over 9 equal to 10 over 16. Would that give us the same thing? Maddie says, I think yes. Okay, right? Because we're using the same numbers, right? 16 and 10, 10 and 16. We're using the same numbers here. But if we do this, let's actually solve it both ways just to make sure whether we're doing this correctly or not. So here, let me rewrite this as, oh, forgot to change my screen mode. Oh, there we go. We can rewrite this as x over 9 equals 10 over 16. Ah, Maddie, great, great. I love that you caught it before we moved on. But we have to change 9 x/9 to 9/x. Exactly. Whenever we flip one of them, we must flip the other as well, right? So that would work. 9/x is equal to 10/16 would work. But now, obviously, this would be a lot more difficult to solve because the x is in the denominator. So we'll have to do multiple more steps. Instead, we already have this x in the numerator in this equation. So we can just multiply both sides by a 9. So x will equal 9 times 16 is 144 divided by 10. I could have simplified 16 and 10 first, but we'll do it here instead. We divide both by 2, and we get 72/5, which is also equal to, let me put this under, that's 14.4. And don't forget, we're not done with the problem until we write our units of measure. Okay, do not forget your units of measure. So, so, so important. Okay, now our brains are activated. Every slide, every problem that we encounter today will become increasingly challenging and increasingly new. And therefore, um, yeah, so stick with me here. If you have any questions along the way, please ask. If you're asking questions, that means you're proactively thinking and you're actively listening and learning. And that's the only way you can you can retain all the learning that you do ever. All right, here we go. Next one. Find the length of line segment CD. Now we have one triangle and we have a bigger triangle, right? You see that smaller triangle within the bigger triangle. So the first thing I do whenever I encounter these types of problems is I redraw each of the triangles. Again, I redraw each of the triangles that I see so that I get a clearer picture of what proportion to set up. Also, it helps me to when I go back and check my work, especially on longer exams and assessments. When I'm checking my work, I know exactly what I'm looking at. And if there's an error, I can point it out right away as well. Because that's why we check our answers, right? We check our answers to see if we've met an error. So here is the smaller triangle. And here is the bigger triangle. All right. So here's A, C, D. We have A and O and B. All right, cool. So AC is 6 centimeters. CD is what we're looking for, right? Find the length of line segment CD. Now, for the bigger triangle, we know that this bottom segment is 17.5 centimeters. And we know this entire piece, AO, is 14 centimeters. Now, the proportion that we can solve for is now very simple. But what was the most challenging part of this problem? If you did not rewrite or redraw these triangles, then you would have never known this is 14 centimeters. The most common mistake students make with these types of problems is that in the proportion, they will use 8 centimeters instead of using the entire segment AO. Okay, so keep that in mind. Keep that in mind. So from here, from here, I can create my proportion. And you try to create it in the chat. I know it's kind of tough to write or type out math on YouTube chat or any message thread, but try your best. Write an equation for this proportion that we have. And we know these two triangles are similar because they share the same angle. We see that these two lines are parallel. And so these are congruent triangles. Right? These are congruent triangles. These are parallel angles. Therefore, this angle is congruent to this angle by corresponding angles. And this angle is also congruent to this angle by corresponding angles given these parallel lines. And we used to call these transversals, right? How many of you have learned transversals yet in geometry class? It's probably coming up if you haven't learned it already. But let's create a proportion off of this. We'll now have x is to 17.5 as 6 is to 14. Now, another way we could have set this up is we could have also set this up as, great, Maddie, you have the same thing I did. You could also do it as x is to 6 as 17.5 is to 14, right? you can start with the same triangle and set up a proportion with the same congruent, or not congruent, but same similar sides in the other triangle. In this case, I see that 6 and 14 both have a common factor, or both 6 and 14 have a common factor of 2, giving us 3/7. And now x will equal, if I multiplied both sides by 17.5, these cancel, giving us 3 times 17.5 over 7. But now I noticed something. 17.5 and 7, let me erase this right part so you don't get confused. 17.5 and 7 have something in common here, right? 7 times 2 is 14. And 7 divided by 2 is 3.5. Notice how 14 and 3.5 make up that 17.5. 7 divided by 2 is the same thing as 7 times 1/2. So if we put together the 2 and the 1/2, that's 2.5. So what I really have here is that 7 goes into 17.5 2.5 times, multiply by that 3. Now I have 7.5 centimeters. And this type of mental math and this type of thinking and relationships created and observed from two different numbers, that comes with practice. And all the problems that I create in my lessons and in the homework problems that you get, or we also call them practice problems, you'll get these types of relationships that'll get you really comfortable with mental math, which is such an important tool and probably the most useful tool in just everyday life, and helps you just move along in life much more easily and more smoothly. All right, let's chug right along. I believe we have 6 more big problems to solve here today, and we've got plenty of time. Here we go. Already over 25% past this hour, by the way. Time is flying. Find the value of x. So again, the first thing I'm going to do is I'm going to redraw the two triangles that I see. So first, I see this smaller triangle, and then I see the bigger triangle. Now, you don't have to draw them to scale, because if you label them like this from our initial diagram, if you label them like this, your teacher can't say anything, right? You've labeled it with the exact points that are on the initial diagram. So we're good, right? We're checking our bases. So we have 15 here. Now, what would the length of AO be here? The length of AO. What would I put as the length of AO? Because right now, if I have that, then I know what proportion to set up. I can set up X is to whatever AO is to 10 is to 15. I just need to figure out what AO is and place it right here. What is AO? How would you write AO given how we solved the problem in the previous slide? All right, Maddie has an answer. Maddie says 12 plus x, comma 15. All right. Yes, the 15 is from the OB. But AO, yes, we want to add 12 plus x. Great stuff, Maddie. Great stuff. So we have 12 plus x here. And now what I can do is I can multiply both sides by that 12 plus x. So let's do that. We're going to multiply both sides by 12 plus x. And this is where your parentheses will become so valuable. You must use parentheses here. And now we have x is equal to, let's simplify 10 over 15 becomes 2 over 3 because both 10 and 15 have a factor of 5. We divide both 10 and 15 by 5 to get those 2/3. So we now have 2/3 times 12 plus x. And I have to remember to distribute the 2/3 to both terms, to all terms within the parentheses. And that gives us, if I move it up here, x is equal to 2/3 times 12. That's 8, right? 2/3 of 12 is 8 because a third of 12 is 4. Double that to get to 2/3 of 12. 4 times 2 is 8, plus 2/3 of x. Now, we have a full x on the left and only 2/3 of x on the right. So what we can do is we can make the full 1x into pieces of a whole of 3 to still maintain that wholeness of a coefficient of 1. We're going to subtract 2/3 from both sides, equal to 8. And this gives us 1/3 x is equal to 8. And from here, pretty simple. We multiply both sides by 3. And this is light work, arithmetic. And don't forget your units of measure, centimeters. Now, the toughest part about this problem, 2 parts, I believe, would be creating this 12 plus x. Probably the first toughest step. The next toughest step, right here. Distribution, right? 2/3 being multiplied to both the 12 and the x. Easy to forget, right? Easy to forget, especially if you forget these parentheses. Don't forget your parentheses. Don't be cheap with your parentheses. Don't be lazy. Always put parentheses whenever you can and should. Okay. The use of parentheses is so, so, so important. All right, here we go. This is where we start to have some fun. So let's look at what happens when we enlarge shapes and calculate the new areas and volumes. Find the area of both triangles given that they have been dilated by a scale factor of 5. Now, a scale factor, boom, new word, new phrase, new terminology. Scale factor means by what factor have we scaled this image? Scale as in the fraction. To what proportion? I had a brain fart there. To what proportion is one of the shapes compared to the other shape? Dilated meaning either we inflated it or we shrunk it, right? So 1 to 5, we multiply by 5, and 4 to 20, we multiply by 5. If we were to go the other way, we divided by 5 by 5 to get to 1, and we divided 20 by 5 to get to 4. So now let's find the areas of both of these triangles. How do we find the area of a triangle? In the chat, how do we find the area of a triangle? The area of a triangle. What is the area of a triangle? And then we can solve for either or for both areas of these two triangles that we see for this first part of this slide. What is the area of a triangle? I know most of you should know this. We're in geometry now. The first time you probably saw this was in pre-algebra in middle school, and then definitely in algebra 1. And now we get to implement this area of a triangle in geometry. And the area of a triangle actually continues to come up even when you get to calculus. This is a really, really important area formula to know. And let's go back to the basics. Reminder that a box is just base times height. But the area of a triangle is when we split that box in half diagonally. So we have the area of a box, and we divide that by 2. We split it in half to get the area of a triangle. Now, let's find the area. So base times height is 4 times 1, and we divide by 2. That's 2. Base times height is 100. 20 times 5 is 100. Divide by 2. That's 50. So now 2 to 50. What did we multiply by? 2 to 50. When we go from 2 to 50, what number have we multiplied by here? What number have we multiplied by when we go from 2 to 50? 2 to 50. 25. Great. 25. So now let's think about this. How does 25 relate to a scale factor of 5? Ooh, I think we're onto something here. 5 and 25. Well, 5 squared is 25. And guess what we're working with here? Area. Area is 2-dimensional. So it makes sense that when we're going from one similar triangle to a dilated version of it, we can square the scale factor and multiply that by the area of the original triangle. Now let's work with volume. Volume is 3-dimensional. So without solving both of these volumes separately, let's see if we can use what we just learned in order to find the volume of the second cube. Gita, welcome. Yes, 1/2 length times base. Beautiful. That's another way to write it. I've heard length times width, base times length, height times width. All of them work. Amazing. So let's solve for the volume of this first. So that's 1 cubed. But now for dilating by a scale factor of 3, and we know we're going in 3 dimensions here with volume, I can multiply by 3 cubed, and that'll give us 27. And don't forget, centimeters cubed. Centimeters cubed. We have centimeters squared here and centimeters squared here. Okay, great. And we know checking the volume of a square of a cube, sorry, volume of a cube with side length 3, we can cube that 3 to get to the 27. All right, let's keep it moving. Here it is. When you dilate a shape by a scale factor of k, and we're working with area, reminder that area is 2-dimensional, which is why we square that scale factor. I am blocking that 2, so let me redraw that circle from the 2. And volume is 3D, so we are going by k cubed. So let's check out this first problem. Shape A is dilated by a scale factor of 4 to produce a shape B. So now this time, they're not even giving us what shape we're working with. They're not even giving us what shape we're working with. All we know is the area of that shape, which is 5 centimeters for shape A. So I'm going from shape A to shape B, and I know the area of shape A is 5 centimeters squared. I know the scale factor is 4, and I'm working with area. So how can I use this information to find the area of shape B? How can I use all this information here to find the area of shape B? The most important thing being our scale factor is 4. Our scale factor is 4, and we are working with area. So how can we solve for the area of B with the given information? What can we do? I'll give you a little bit of time to think about this. I gave you a little hint in this yellow box as well. Whenever we have a scale factor and we're working with areas, great, Maddie. 4 squared? Yeah, right? Our scale factor is 4, k is 4, and since area is dilated, area is 2-dimensional, so we can square that scale factor and multiply, right? Great. Yeah, 16. So 5 times 16 is 80 centimeters squared. And it's really that simple, right? Can you imagine that we're doing this, right? It's so crazy that we're doing this with just the given information without even knowing what this shape is, right? That's the craziest part. So now shape A is dilated to produce a shape B. The area of shape A is 10 centimeters squared. Okay, yeah, Maddie, we're getting it. Here we go. The area of shape A is 10 centimeters squared, and the area of shape B is 250 centimeters squared. Hold the phone. All right, this time we are given the areas of both shapes. Okay, let's write that down. So A, the area is 10 centimeters squared, and for B, the area is 250 centimeters squared. Okay. So what are we multiplying the area of A by to get to the area of B? Well, 10 times 25 is 250, right? So we're multiplying by 25. And the last time I read this, we were working with area. So area dilates by a scale factor of k squared. So would it make sense for us to say k squared is equal to 25? Because we multiplied the area of shape A by 25 to get to the area of shape B. And this is a relationship that we observed from the 10 and the 250 that we see. So k will equal, if we take the square root of both sides, k will equal 5. Now, we know that the shape B has length 2.5 centimeters. And now we're going backwards to shape A. If the length of one side of shape B is 2.5 centimeters, what operation can I use here going backwards to get the length of of that same respective side of shape A? Yes, Maddie, great. 5. K equals 5. What can we do here? Now, we're working with lengths now, which are one-dimensional, and we notice that this centimeter is no longer squared, right? Because length is one-dimensional. So we're not going to be dividing by 25, right? We're going in the opposite direction. Great, Maddie. We are going to be dividing by 5. Awesome work. We're thinking now. 0.5 centimeters, and that is our answer. Beautiful. Now, let's raise it up a notch here. 3D shapes below are mathematically similar. If the surface area of shape B is 22.5 meters squared, what is the surface area of shape A? Wow, okay, big one here. So shape A, the surface area is 22.5 meters squared. Again, setting up these problems is also a skill, and that's what we're practicing as well. That's what I'm modeling here. You'll be able to practice these using your practice problems. But here we have shape B to shape A, and the surface area, this is what we are looking for. Now, we are given volumes. What are we multiplying 5 by to get to 135? Well, 135 divided by 5 is 27. 27. Notice how we're working with 3 dimensions here because we're working with volume. Volume is 3-dimensional, and we see that it dilates by a scale factor of k cubed. We know that the dilation was 27 times the initial shape. So now we have k cubed is equal to 27. So what is k equal to here? What is our scale factor for this problem? Knowing that this is shape A, this is shape B. 3. Beautiful, Maddie. So we have 3. Now, we're working with surface areas here. Surface areas are dilated by a scale factor of k squared. So we know that this is going to be 3 squared. But are we going to be dividing or multiplying here, going from the surface area of shape B back to the surface area of shape A? Are we going to be multiplying or dividing here? If you get this, I believe you are ready to move on from here. You've mastered the similarities dealing with areas and volumes. Because right here, we are tying together both areas and volumes. Great, Maddie. We are dividing, and this is how you know. I know you put a question mark there because you're thinking, you're slightly guessing, but it's an educated guess, and I can tell. But this is why. When we go from A to B, we multiplied, right? We grew in size. So if we're going, even with areas, if we're going in the opposite direction, we must do the inverse of the operation that we did before, right? Going in the other direction. So going forward from A to B, we multiply by 27. So going backwards from B to A, we must divide by 9. And 22.5 divided by 9 is actually a cool number. 9 goes into 22.5, 2.5 times. 2 times 9 is 18. That leaves us with 4.5 out of 9, which is a half. So I have 2.5. And don't forget your units. What would be your units of measure here for this 2.5? What would be your units of measure for the 2.5? What would be the units of measure for this 2.5? It's not meters cubed. We are working with area here. And area is 2-dimensional. Great. And that's how we know it's meters squared. Awesome work, everyone. Great stuff. Let's keep going. So here's the first application, and here's the second application. So we're ending with a word problem today. But before that, let's work with one more problem here. In the diagram below, EB and DC are parallel. So what that means is that we have congruent triangles. We have, similar triangles. We have, boom, the same angle. This angle is congruent to this angle, and this angle is congruent to this angle. Therefore, we have congruent triangles, which also happen to be similar in this case. So now, we can redraw these triangles as such. And again, doesn't matter if it's not drawn to scale because we are going to label them A, E, B, A, D, C. And as long as we label them, we're okay. Okay. As long as we label them, we'll be okay, even if it's not drawn to scale, because we've took it straight from the points in our original diagram. So here's 9, here's 9.2. We want to figure out the length of AC. So this is the X value. This is our unknown that we want to find. And we know that AD here is equal to 14 because we add the 9 and the 5. Again, the first mistake that students may make in this problem. And let's set up the proportion. This one's pretty simple. X over 14 will be equal to 9.2 over 9. And now we multiply both sides by 14. And let's do that on a calculator. And I'm going to open up my calculator, and I see 9.2 divided by 9 times 14. Boom, 14.3. They want me to find the length to the nearest tenth, So I have 14.3. And don't forget, whenever we are estimating, we must use the squigglies. So we have 14.3. And were we given units? We were not. So we're all done. So AC, it's not 9.2 plus X. Great point. Great point, Maddie. If we were asked to find BC, I would have called that X. But in this case, let me not call it X. Let me call it something different and use a different color as well. Let's call it BCY. If they asked for BC instead of AC, then we would be looking for what Y is equal to. In order to find Y, that's actually a new problem here that we could solve. We could just take the X and now subtract 9.2, right? Do you see that since 9.2, let's rewrite this. Since X is equal to 9.2 plus Y, in order to get Y by itself, we get X minus 9.2, which is approximately, if we do 14.3 minus 9.2, that would be approximately 5.1. Great question, Maddie. You just took us to the next level here, right? By thinking, by asking questions like that, you just gave us a new problem within this problem that would have made this problem a little bit tougher. Great question. Did that make sense, by the way? Just want to make sure you got it. Awesome. Beautiful question, Maddie. All right. Our last problem for today, and look at that, we're already 40 minutes in. Of course. A street lamp casts a shadow 16.4 meters long. Okay, let's check this out. And I'm actually going to exit out so that I can draw better lines here. I'm going to insert a line. So we have a street lamp. Let's say this is our street lamp. And it casts a shadow. And this is the shadow that it casts. Right, let's say this is the shadow that it casts. And that is 16.4 meters long. And we'll type that in a little bit. Michelle stands 12.55 meters from the base of the street lamp. So let's say Michelle is about this far away and that tall. Now, the end of Michelle's shadow meets the end of the street lamp's shadow. So what this means is that Michelle's shadow here is going to meet the street lamp, right? The base of the street lamp's shadow as well. So what we can do, we can extend this line actually all the way. And let's do this. And let's make Michelle a little bit shorter here. Boom, there it is. And now we have two triangles that we are very, very familiar with solving. Let's check it out. So let's fill this all in. We have this entire length right here on the bottom is 16.4 meters. We know that Michelle stands at 12.55 meters. And we know, oh, oops, that's incorrect, right? 12.55 meters should be from here to here. That's 12.55 meters. So I'll write 12.55 meters, and we'll do this thing. Maybe you've seen your teacher do this before. It's to notate lengths when you don't want to overlap information. Now, Michelle stands at 1.52 meters. So 1.52 meters is the length of this right here. And now I want to know the height of the street lamp. That is my unknown. Are we able to solve this? Let's take a look. We have this smaller triangle, and we have this bigger triangle. Now, in the smaller triangle, we have 1.52. And in the bigger triangle, we want to solve for h. So we already have one of the proportions set up, right? We already have h over 1.52 is going to equal something. Now, we know that this is 16.4 meters. So I know h is to 1.52 as 16.4 is to this length right here. What is this question mark? That's this right here. Well, we have the entire length on the bottom, and then we have a smaller length. Why don't we subtract? Right? 16.4 minus 12.55. Exactly, Maddie. Step ahead of the game right here. Amazing work. So that would be 3.85. Just some quick maths there. Amazing. And now we can multiply both sides by a 1.52 times a 1.52 and see what we get for h. And I'm going to put squigglies here because I feel like we're going to be estimating since we were told to find the nearest tenth of a meter. So I'll plug this into a calculator, erase our initial one. We'll have 16.4 divided by 3.85. I'm going to get that first and multiply by 1.52. And that'll give us 6.47. They asked for the nearest tenth, which means this value right here. And this 7 will round the 4 up to a 5. So we have 6.5. And don't forget, whenever we're given units of measure in the problem, we must include it as a part of our answer. Just like that. Maddie, this felt like a one-on-one tutoring session today. That was awesome. That's probably why we went so quickly today as well. In my courses, there are several students already signed up. So we will have more questions in the chat. We will have more dialogue in the chat, more participation as well. But Maddie, appreciate you for participating today. If you enjoyed today's lesson, call your parents over right now and we can go ahead and get started with this. Oh, what's wrong with my green screen? I look a little spooky. Just in time for October, right? So our lesson may be ending, but your progress doesn't have to. At my EdSpace, my geometry full year course starts next Monday. In exactly 1 week from now, starts on October 6th. Each course will include 2 engaging live and interactive lessons each week, just like the one you saw today. Twice a week, geometry will meet Mondays and Wednesdays, 6 to 7 p.m. Pacific time. Video recordings to revisit lessons. All lessons are recorded, so you don't have to worry about missing anything ever. You'll be able to access them through the entire academic year from October 6th all the way through June, through the month of May, and then to June of 2026. Professionally designed workbooks that you were able to access today in the video description, that very first link. And after every lesson, you will get practice problems, 5 practice problems, exam-style questions that will help you check your understanding and see if you truly mastered the material. Now, I don't leave you hanging on these problems. I make detailed video solutions on each of these problems so that you know, it's like an extra lesson, you know exactly what you may have done wrong or a different way that I used to solve the problems that you practiced. But how much is it? For context, when I used to be a private tutor, uh, I was volunteering in high school, basically pro bono, which means for the public good. And it was completely free. The tutoring I did when I was in high school and in college, that went up to about 30 to $40 an hour. But I didn't really know what I was doing, right? It was mostly homework help. And then, 5, 6, 7, 8, 9 years into teaching now, I used to charge a minimum of $100 an hour to 200 per hour because now I know exactly what the teacher is going to be teaching, the types of problems that will be on their upcoming exams, things like that. I charged a lot more because now I have that experience. And that's the problem with private tutoring. Families always have to choose between what works and what they can afford. Um, Effectiveness versus affordability. Very rarely and almost never both. And that's why we created My Headspace. All of this for just $99 a month, which is probably one session with a tutor, like one hour session with many, many tutors out there. But you get 7 to 8 lessons per month for $99 a month. And on top of that, all of it's recorded, right? Your private tutoring sessions are never recorded. So sometimes you forget what you even covered. Practice problems with exam style questions. Rarely do you get practice from your tutor as well. You're just given homework help. And then also the detailed video solutions. You're never left hanging. You don't have to try to catch your tutor in the middle of the week and pay extra for talking to them. There's your video solutions right there for you. 8 times cheaper, right, than what I used to charge. Now, why stop there? If you are interested in registering for the entire annual package, totaling of up to of 60 live lessons over the course of 8 months, I am offering a 20% additional discount on the annual package. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. It is a first come first serve basis. It's a limited time offer. So if you're interested, text me the code word START to my number, 512-900-1283, or scan this QR code and it should prompt you to send the code word straight to that number. So I hope you enjoyed today's lesson. It was very quick because, I mean, the participation was so automatic. Um, and the chat was active thanks to Maddie. But yeah, if you have any questions, I'll be here for a quick Q&A. If you have any questions about my course, feel free to chat it through. I'll be here for a couple minutes. Ask your questions. Or if you're interested in talking to me offline, send that code word START to my number. Otherwise, I'm on socials, EddieDoesMath on TikTok, Facebook, YouTube. You're here. And Instagram as well. EddieDoesMath. On Instagram, I believe my handle is EddieDoes.math. And I've been uploading content there as well. Some really helpful stuff, SAT prep, some cool tricks that you can use in your math class and everything like that. I'll be here for another 30-ish seconds. So if you have any questions, feel free to ask. Otherwise, have a beautiful rest of your evening. Thank you for joining today. Tomorrow, I'll be teaching a free lesson on Algebra 2. And then on Wednesday, pre-algebra. On Thursday, Algebra 1. So if you're interested in those, feel free to sign up as well. And you'll be able to see that sign up link on my Instagram, EddieDoesMath, in my bio. All right, everybody. Thank you so much for your time again. Enjoy the rest of your evenings. I will see you next time. Bye-bye.